We are going to continue solving the problem that we were working on. This is the example that we were solving. We had to use the trigonometrical identity sine squared a plus cosine squared a equals to 1. We already finished all of this. We calculated the solutions of the quadratic equations when it is in the form of x. Let's continue. This is the quadratic equation. We said let sine x be capital X. After solving, we got two values, capital X equals minus 1 over 5 or plus 2. Now we need to substitute. Sine angle X equals minus 1 over 5, and here it equals to plus 2. Pay attention that the sine as a value, regardless of the angle, is always between minus 1 and 1. That means it cannot be plus 2. So this equation has no solution because the sine cannot be any value that is greater than plus 1. We will rely on this factor only, which is minus 1 over 5, and it will give us the solution of the angle. X is sine minus 1 for minus 1 over 5. Remember that interval x is between minus pi and pi. Now, we will use the calculator, and you should be sure that the unit is in radians. Okay, so shift sine minus 1 over 5. The answer is minus 0.201. This is the first angle in radians. Now we need to represent it on the quadrant plane. The first angle is minus 0.201. X is between minus pi and pi. So this is 0. If we move from here clockwise, then this will be minus pi. This is the first part of the angle. The second part is from here, and we move anti-clockwise, and here we have plus pi. So it is a full cycle. The first time you move anti-clockwise in order to reach plus pi. The second time you move clockwise in order to reach minus pi. Now we need another angle where the sign is negative. In this quadrant, the sign is positive, so not here. Also here, the sign is positive, so we neglect this one as well. In the third quadrant, the sign is negative, so we accept it. This is the angle. It is acute, and it is 0.201. In order to find this angle, it has to be within the range. We cannot say it is pi plus this part because it will be greater than pi. So we are going to say the following. Minus pi plus 0.201. The answer is minus 2.94 radian. This is the second angle which achieves this quadratic equation in the trigonometric ratios. You can solve these exercises in the same way. Look at exercise 3, part E. We have a mix between sine and cosine. So here you need to use the identity and to change the equation to have only one variable or trigonometrical ratio.